The next major topic we're going to address is units. And we've already talked a little bit about units, and we've seen that units tell us what it is that we are measuring. So distance, time, energy, volume. And the unit that we choose should be appropriate to the magnitude of what we are measuring. For example, if we're trying to measure a person's height, it would make sense to use feet. It might make sense to use meters or centimeters, but it wouldn't make sense, say, to use miles. You could do that, but it would be pretty strange. Miles would be more appropriate for measuring distances between cities. And if we need a really large magnitude distance unit, something like light years or parsecs would be better suited. So, for example, between distant galaxies, and we want to measure those, light years is the most common method. Now, I'm sure at this point you're somewhat familiar with the English system, even though you might not know that it was called that. And the English system contains many different familiar units like inches, feet, miles, all of those being units of length, liquid ounces being a unit of volume, and pounds and tons being units of weight. And although it is in common use, there's one very serious problem with that, and that has to do with the way these units relate to one another. For example, inches to feet. There are 12 inches in a foot. Okay, let's go to the next unit up. Feet to yards. Well, there are 3 feet in 1 yard. What about miles? Well, there's 5,280 feet in a mile. You see, it's fairly inconvenient to have to remember all these different numbers to relate one unit to another. There's no pattern, rhyme, or reason for these numbers. They're all just based on historical precedents. So that makes it very inconvenient to deal with. The metric system, on the other hand, is always based on powers of 10. So either the number 10 directly or the number 1,000, which is itself a power of 10. So, for example, if we're looking at units of length here, we know that there are 10 millimeters in a centimeter, 10 centimeters in a decimeter, 10 decimeters in a meter. You'll see that these all contain the word meter, which tells me what type of measurement I'm doing. It is a measurement of distance or length. And each of these prefixes are going to be representing some kind of a power of 10. And so all you need to know is what each prefix means and what each base unit means to tell you how you can convert from one unit to another. And so they're used across a wide range of measurements: volume, time. Let's just think of some common ones. Like for volume, we often measure in liters, and if we need a smaller volume, milliliters is common, and if we need to go even smaller than that, microliters. So in the SI units, again that's another term for metric units, here are our common base units. So these are going to be the words, as it would be, that we have prefixes for. So meter would represent length units. So we would have kilometers or millimeters or centimeters. All of those would be some kind of a length measurement. Grams are the base unit for mass. I've put an asterisk here because technically what we call the official SI unit of mass is the kilogram. However, I just want to draw your attention to the point that any mass unit will have the word gram in it, and that's why I put that here instead of kilogram. We won't have a millikilogram, we'll have a milligram. And the abbreviation for that is the small letter G. I'm not going to read through all of these, but I will say that we will talk about Kelvin in the next video. And when we get to chapter 5, we will talk a lot about moles. And we'll see liters coming up soon as well as seconds. Now this table is probably very intimidating when you first see it. This is a fairly comprehensive list of the different prefixes you're most likely to encounter, although, believe it or not, there are additional ones that are not listed here. Now, you are not going to need to memorize every one of these prefixes, so let me just show you first of all which ones I'm going to need you to know. So I've indicated the 5 that are most important that need to be memorized here with arrows. And let's just go through what they mean. So let's say we're looking at kilo. So kilo is the full name. It can be abbreviated with a K, which means the full word for mass might be kilogram, but the abbreviation would be kg, because G is the abbreviation for gram. And then this means the same thing as 10 to the third. That's the power of 10. We know that 10 to the third is 1,000. So these are equivalent ways of expressing it. So what K does is it effectively stands in for the number 1,000. So when we see kilogram, we could read kilogram as 10 to the third grams, or 1,000 grams. Kilometer would mean 1,000 meters. 1 kilometer is 1,000 meters. If we go to one of the smaller units here, like for example milli, the same thing is true. Milli means 1,000th. So that's represented by 10 to the minus 3. So a millimeter is 1,000th of a meter. So 1 millimeter is 10 to the minus 3 meters. The one that might be unfamiliar here is micro, which uses this Greek letter mu, and we ran out of m's, as you can see. We used the capital M for mega, we used the small m for milli, we need one more m for micro, so that's the Greek letter mu, and that stands for millionth. If I want to use any of these other units like pico or femto or giga, I will explicitly give you their definitions on any assignments or exams. So now we look at how do we convert from one unit to another. And it's important that you understand the theory behind this so that when you're constructing your conversion factors that you're doing it correctly. So let's just build up some theory. So first of all, you'll notice in many different books, and you'll find all these different equivalences between units. So this one should be a very familiar one. 1 foot equals 12 inches. This is an equation. Now, as we know from algebra, we can divide both sides by the same quantity, and the equation is still valid, so long as you're not dividing by 0. So I'm going to divide by not just 12, but by 12 inches. And what do we see here? So on this side we have 1 foot divided by 12 inches. On this side I have 12 inches over 12 inches. The 12s would cancel. Inches work just like x or y in algebra. They would cancel as well. So 12 inches over 12 inches would just be the number 1. So this is an important idea. 1 foot over 12 inches is the same thing as the number 1. And what's special about the number 1? Well, we know from algebra that when you multiply something by 1, it doesn't change it. It's still the same thing. Now, we can multiply by 1 in many creative ways in algebra. Like, you could multiply by 3 over 3, right? 3/3 is the same as 1. And that's essentially what we're doing here, is we're just coming up with a very interesting fractional version of 1. So long as the numbers and the units are matched correctly, you get one of these guys right here, which is going to be called a conversion factor. All we did was change an equation into a factor. So conversion factors are essentially fractions which have different units in the numerator and denominator. And since those numerator and denominator measurements are equivalent, multiplying by them does not change the value of a measurement. It will certainly change a number and it will change a unit, but it's going to be the same distance or time when you multiply by that. So when we look at this equation right here, we can see that we can get two conversion factors. In the last slide, I divided both sides by 12 inches. I could have just as well divided both sides by 1 foot. And these are the two conversion factors that we get. It's very important to double check and make sure these are the same thing. And since there's an equation, the numerator and the denominator stand for the same thing. So let's say we want to put this conversion factor to use. So I would like to convert 18.5 feet to inches. Please do not approach this problem by just saying, oh, I multiply by 12. No, if you do that, you've missed the point because you will ultimately not see the pattern that you're going to need throughout the next several chapters. So it's important that you look at the process. So I want to use a conversion factor that gets rid of feet but leaves inches. Do I know such a conversion factor? Of course, I just saw one a moment ago that would do that. So I want to use the conversion factor that has feet in the denominator and inches in the numerator. So I've got 18.5 feet. Feet, as I said, needs to go in the denominator, inches in the numerator. You'll notice I always go this way. I always go numerator down diagonally to the denominator, and then if there's going to be another conversion, I'm always going to be looking at the diagonals. Okay, do units cancel? Indeed they do. The feet cancel out just as if they were an x or a y in an equation, and then we have 18.5 times 12 divided by 1. And this would give me 222 inches. What about sig digs? Well, remember, 12 and 1 are defined quantities. They're exact numbers then, so we don't look at them for sig digs. 18.5 has 3 significant digits, so our answer should have 3. Now this process can be somewhat more confusing when we're using metric units when you first start doing it. But if you find a consistent way to do it, you're likely to have no problem with this. So you need to be able to write a relationship between the prefixed unit and its base unit in two different ways. So let's say we wanted to go, for example, between centimeters and meters. So I'm going to call this a prefixed unit because it has centi, a prefix on it, and that is the base unit, meter. And I can come up with two different equations for that. I can say that 1 centimeter is 10 to the minus 2 meters, or I could say equivalently 10 to the second power centimeters is equal to 1 meter. Of course, 10 squared is just 100. So that would allow me to have as many as 4 different conversion factors. These top two conversion factors come from the first equation, and the next two conversion factors down here come from the second equation. Now I'm going to be very consistent, at least throughout the first few chapters, in how I'm going to do this. And I strongly recommend that you do it the same way that I do, because it's, as I said, consistent, and it will never go wrong if you always do it the same way. And that is, when I have a prefixed unit and its base unit, so centimeters, meters, or millimeters, meters, or milliseconds, seconds. So whenever I have any of those kinds of things, I always prefer to put 1 in front of the unit with the prefix. And then what the prefix means on the other side. Let me explain why that works. Remember, we said centi means 10 to the minus 2. So what is this? 1 times 10 to the minus 2 meters. 10 to the minus 2 meters. The c means 10 to the minus 2. And so therefore, it's very easy to do this correctly, to read it and not make any mistakes or get them backwards. The bottom method is also technically correct. You'll notice the big difference is, instead of putting a 1 in front of the prefix, we put the inverse of the prefix there. So centi means 10 to the minus 2. We've already said that, right? So 10 to the positive 2 times 10 to the minus 2 gives you 10 to the 0, or 1. And I think that most people find that more confusing. I think it's easier to do in words, though. 10 squared is 100. Centi is hundredth. And whenever you have 100 hundredths, that would be 1. If you have the opposite, a hundredth of 100, that would be 1. So whenever they're opposites like that, you get 1. So a million millionths, a thousandth of 1,000, or 1,000 thousandths. All of those would work too. The book sometimes uses both of these, although they don't usually like to use powers of 10 to the same extent that I do. So I'm going to prefer to write it out like this, and I'm going to just stay consistent with that throughout. So, in summary, I put a 1 in front of the unit with a prefix, and the meaning of that prefix in front of the base unit. Now sometimes I will use other conversions just because it's easier, like 1 liter is 1,000 milliliters. We make that conversion so often that it's best to not even deal with the powers of 10 and just memorize that one. The same thing here with centimeters and millimeters. It's probably just easiest to memorize 1 centimeter is equal to 10 millimeters. It'll save you some time. So, let's do this conversion here. How many centimeters are in 9.86 meters? In other words, we want to convert 9.86 meters to centimeters. So the unit I want to get rid of is meters, and the unit I would like to have is centimeters. So following the procedure that I just used a moment ago, I put 1 in front of the unit with the prefix, so 1 centimeter, and then what the prefix means on the opposite side. The centi means 10 to the minus 2 in front of meters. And there we cancel out our meters, and we're left with 986 centimeters as the answer. Another thing here to notice is that whenever you go from a larger unit to a smaller unit, the number must always do the opposite. So meter to centimeter, the unit got smaller, the number got larger, 9.86 to 986. Also, if we want, we can simplify this a bit by just getting rid of the multiplication sign. There's no reason that we need to have it there. Let's do another conversion that involves using the SI system. How many nanoseconds are in 2.83 milliseconds? Well, this problem is going to teach you a vitally important technique. You never want to try to go from one unit with a prefix directly to another unit with a prefix. You need to do this in steps. So we don't know how many nanoseconds are in a millisecond, but we do know how many milliseconds are in a second. And similarly, we know how many seconds are in a nanosecond. So we're going to do this in 2 steps, although we're going to write it out in one long step. So our given unit, our starting unit, is 2.83 milliseconds. I would like milliseconds in the denominator and seconds in the numerator. And you see what that will do is cancel out the milliseconds. Ask yourself, does this make sense? 1 is in front of the unit with the prefix. Good. The prefix means 10 to the minus 3, so that's on the other side. Good. This all makes sense. Now I want to cancel seconds, so I'm going to put seconds in the denominator, and I want nanoseconds in the numerator. So a lot of people will write this upside down and get this wrong. But remember, we said a 1 goes with the unit with the prefix, so 1 nanosecond. And the meaning of nano is 10 to the minus 9 seconds. Now let's look at everything that crosses out, milliseconds and milliseconds, seconds over seconds. So the unit that's left over is nanoseconds. And when we put this in the calculator, we should come up with 2.83 times 10 to the 6th nanoseconds. Your textbook provides you on page 12 with a nice list of different conversion factors between English units and the metric equivalents. Some of these need to be memorized, and those specific ones I want you to know are boxed in right here. So 2.54 centimeters, 1 inch, grams to pounds, liters to quarts. Those are all done often enough that you really ought to know them by memory. It also would not hurt if you knew, for example, quarts to pints, gallons to quarts as well. But if those aren't memorized, that's not going to be a problem for this class. Now let's look at another type of unit we want to measure, and that is going to be volume. So the SI unit of volume is the liter. But in this class, we're more often going to work with milliliters. It's a much more convenient unit. The cubic centimeter is also important, and in medical contexts, the cubic centimeter can be written as either centimeter cubed or cc. So these are all equivalent. That's very important to know. A milliliter is the exact same thing as a centimeter cubed, which is exactly the same thing as a cc. We tend to use milliliters for measuring liquids and gases, especially liquids, and centimeters cubed for solids. So let's say we want to take a look at this question here. A container holds 1.50 pints of liquid. How many milliliters is this? How many cubic centimeters? Well, before we answer that, let's think back to what I need to know. I want to get to milliliters. I don't know pints to milliliters, but I do know pints to quarts. That was on the previous list. Let's just go back for a moment and take a look at those. So I know pints to quarts. What else do I know? I know quarts to liters. 1.06 quarts is a liter. I also technically know that 1 quart here is 946 milliliters. For the time being, let's just say we didn't know that. I want to just use the full conversion so that you can see the whole process here. So I'm going to go from pints to quarts, quarts to liters, and then liters to milliliters. So let's write this out here. And it's sometimes helpful if we start by writing what I call a guide map here. So I know I'm going to want to go from pints to quarts. I'm going to want to go from quarts to liters, and liters to milliliters. So we'll start off here with 1.50 pints. So I want pints to cancel out. So I'm going to put pints in the denominator and quarts in the numerator. You see these arrows basically stand for a conversion factor. So there are 2 pints in 1 quart. I can go ahead and cancel out pints now. I now want to go from quarts to liters. Well, I know that there are 1.06 quarts in 1 liter. So I can go ahead and cancel out quarts. And now I want to go from liters to milliliters. And you might say at this point, oh, well, you know that there's 1,000 milliliters in a liter. Yes, I do. But I want you to get used to writing these out the correct way so that you're not making mistakes later on. So milliliter to liter. Remember what I said to do? We're going to use a 1 in front of the unit with the prefix. So 1 milliliter. And then down here I'm going to use 10 to the minus 3. That's what milli means. So liters cancels with liters. Alright, so I'm going to go ahead and put this in the calculator. Now I'm going to read out exactly how I solve this. Since all of these numbers are in the denominator, I'm going to divide by all of them, and that will get me the correct answer. So I have 1.50 divided by 2 divided by 1.06 divided by 10 to the power negative 3. And when I do that, I'm getting 707.5 and the unit is milliliters. And now we need to look at significant digits. So our starting number had 3 significant digits. Quarts to pints is exact, so we don't look at those numbers. Liters to quarts technically are not exact. The 1 is considered exact. The 1.06 is 3, but for right now, I don't want to complicate things. I just want you to think that that's an exact number for now. And all of the unit conversions from SI to another SI are exact. So really, the only number that we have to go on for significant digits is 3. We need 3 significant digits. So how are we going to do this? 1, 2, 3 significant digits. The 5 tells us to round up. So the correct answer would then be 708 milliliters. How about cubic centimeters? Well, we said a milliliter is the same as a cubic centimeter, so it would also be 708 centimeters cubed. That would also be an equivalent volume. I'm going to go ahead and end the video at this point, and I'll resume with more uses of conversion factors, and then we'll look at temperature and density. Thank you.